For 2 decades, three engines looked like the future of aviation. Boeing 727 dominated the skies, and wide-body trijets like the McDonnell Douglas DC-10 and Lockheed L-1011 Tristar opened long-haul routes that twin-engine aircraft weren't even allowed to fly. Airlines literally invested billions in these planes, and passengers got used to seeing that distinctive tail-mounted engine at airports worldwide. And then, almost overnight, they were gone, undone. Not just by one thing, but by a perfect storm of shifting economics, tragic accidents, and a surprising regulation change no one saw coming. This is the story of the fastest extinction in aviation history and why being the perfect solution today doesn't guarantee you'll survive tomorrow. To understand what really happened, we need to rewind back to the 1960s. Aviation was trapped in a regulatory box. Regulatory standards were crystal clear. Twin-engine aircraft could not fly more than 60 minutes from a suitable airport on overwater flights, cross the Atlantic in a twin not without comprising on routes significantly impacting economics. Four-engine jets could fly anywhere, but burned massive fuel and cost fortunes to maintain. Airlines needed a solution that could access long routes without the crippling economics of four engines. The answer seemed obvious. Three engines. At least it looked obvious under the rules of the time. Rules that wouldn't stay the same forever. Europe moved fast. The Hawker-Siddeley Trident flew in 1962, targeting short European routes with three rear-mounted engines. It entered service in 1964 with BEA, a predecessor of British Airways. But America saw bigger possibilities. Boeing launched the 727 in 1963, with 80 orders before the first aircraft even flew. Three engines mounted at the rear kept wings clean for better aerodynamics. Short runway capability that four-engine jets couldn't match. The 727's iconic rear air stack enabled quick boarding at smaller airports, making it a favorite among passengers and crews. The 727 became aviation's Swiss Army knife. By production's end, 1,832 aircraft rolled off the line. For years, it was the best-selling airliner in history. Then came the real game-changer, the McDonnell Douglas DC-10 in 1970. Aviation's first wide-body Trijet could cross oceans with around 270 passengers in a single cabin configuration, while meeting every ETOPS regulations. Such airlines like American Airlines, Continental Airlines, and United Airlines placed large orders. Here was an aircraft that solved aviation's biggest regulatory headache while making serious money in the tri-ine wide-body market. Lockheed responded with the L-1011 Tristar in 1972. Autoland capability, automated descent control, the most advanced avionics package ever installed in commercial aircraft. By the mid-1970s, trijets ruled the sky, but things were about to take a nasty turn. But before we get on to that, we need to discuss why trijets were so compelling for airlines. The DC-10's distinctive tail-mounted engine became a planespotter's hallmark, symbolizing the trijet's bold design. The performance benefits looked substantial. Higher thrust-to-weight ratios meant better takeoff from shorter runways. DC-10s and L-101s could serve thinner long-haul routes that would never justify 747 capacity. Wide-body trijets revolutionized international flying. Instead of needing around 400 to 500 passengers to make money, airlines could operate DC-10s with 250 seats and easily profit. KM used DC-10S to connect Amsterdam with destinations that would never support 747 service. American Airlines built its Pacific expansion around the aircraft. TWWA made the L-1011 its international backbone. The economics seemed compelling. Cheaper than four-engine aircraft, more capable than twins, compliant with ETOPS regulations. Fleet commonality meant lower training costs and simpler crew scheduling. One aircraft type could handle both high-density domestic routes and long-haul international services. For 2 decades, three engines represented aviation's future. Airlines couldn't order them fast enough, but warning signs were appearing that nobody wanted to acknowledge, and those warning signs had names. The 1970s brought challenges Trijet designers never anticipated. Oil crises in 1973 and 1979 sent fuel prices through the roof. Suddenly, efficiency mattered more than regulatory compliance. Then came the accidents that shattered public confidence forever, at least in the DC-10. March 3, 1974, Turkish Airlines Flight 981, a DC-10's cargo door, failed midair, causing the floor to collapse, severing the aircraft's flight controls. 346 people died. The cargo door's latch design was fundamentally flawed, appearing secure when actually it was not. May 25, 1979. American Airlines Flight 91. The DC-10's engines separated during takeoff from Chicago O'Hare. The aircraft rolled inverted and crashed, killing 273 people. Metal fatigue in pylon attachments and incorrect maintenance procedures caused a catastrophic failure. The entire DC-10 fleet was grounded for 37 days, a major reputational hit. Though design fixes followed, the DC-10 later became known as the death coffin in media coverage, and public perception never recovered. The L-1011 faced different but equally devastating problems. Rolls-Royce went bankrupt and was rescued by the UK government during the RB211 engine's development, resulting in massive delays and cost overruns. Delivery schedules were thrown into chaos. By the time the Tristar finally entered service, the DC-10 had captured most of the market. Lockheed never recovered its development costs and eventually exited commercial aviation entirely. But even these setbacks weren't the real danger. The real threat was waiting in the wings, a new class of engines that would erase the very reason trijets existed. Design complexity was also becoming a liability. Center-mounted rear engines were problematic to maintain. Access required special equipment, resulting in extensive downtime. Operating costs exceeded all predictions. Airbus and Air France introduced the A300 into commercial service in 1974, Europe's first wide-body twin, promising 30% fuel savings compared to trijets. Boeing responded with the 767 program in 1978, with the type entering service with United Airlines in 1982. The writing was on the wall, but there was still that 60-minute regulation keeping twins off transatlantic routes. That protection was about to disappear through a transformative shift. And when it did, trijets would go from unstoppable to obsolete in record time. Extended Range Twin Engine Operations, or ETOPS, the regulation that killed an entire aircraft class, arrived in 1985, shattering trijet dominance overnight. ETOPS started with 120-minute approval, allowing twin jets to fly up to 120 minutes from the nearest suitable airport. This opened most transatlantic routes to twins. Trijets lost their primary competitive advantage overnight. Boeing 767 and Airbus A300 with superior fuel efficiency outmaneuvered trijets, marking a pivotal manufacturer rivalry that reshaped aviation. Airlines ran the numbers immediately. A twin engine used less fuel than a trijet with similar passenger loads, lower maintenance costs, and smaller crews. Orders for trijets slowed dramatically as airlines pivoted to 767s and Airbus A300s. This didn't stop new trijets being made, however, but ETOPS didn't stop at 120 minutes. The regulations kept expanding rapidly. 180 minutes by 1988, covering virtually every commercial route worldwide. Eventually 330 minutes for the most reliable twins. The competitive case for trijets had completely collapsed. Modern twin engines weren't just more efficient, they were incredibly reliable. The current approval standard for 180 minutes, ETOPS, requires just 0.02 shutdowns per 1,000 hours of engine operation. Twins were actually becoming safer than the older trijets. If airlines could serve every route in the world with twins, why would anyone choose 3 engines? They wouldn't, and they didn't. What happened next shocked everyone in the industry. What took 20 years to build disappeared in less than a decade. The Boeing 727, once the world's best-selling airliner, suddenly looked ancient. Airlines replacing aging fleets chose new Boeing 737 and Airbus A320 families instead. Similar capacity, dramatically better fuel efficiency, lower operating costs. Delta operated 191 Boeing 727s for over 30 years. But by the 2000s, even Delta was retiring their Trijet fleet for more efficient alternatives. Long-haul Trijets died even faster. The 446 DC-10 and 250 L-1011s had been rapidly replaced by 767s, 777s, and A330. Fuel savings were massive, sometimes 40% or more. DC-10 passenger service ended in the early to mid-2000s with some exceptions. The L-1011 retired even earlier due to smaller fleet size, high costs, and part scarcity. McDonnell Douglas made one desperate final attempt to save the concept. The MD-11, which entered service in 1990, marketed as an efficient long-haul replacement for the aging DC-10, it failed spectacularly. The MD-11 struggled to meet performance expectations, particularly fuel efficiency and range in challenging conditions. The Boeing 777, entering service in 1995, outperformed the MD-11 with better fuel efficiency, longer range, higher capacity, and just 2 engines. Only 200 MD-11 passenger versions were built before the program was relegated to freighters. But Trijets found unexpected salvation. Cargo carriers like FedEx, UPS, or Lufthansa Cargo bought new and used DC-10s and MD-11s at bargain prices. In cargo operations, payload capacity mattered more than fuel efficiency per passenger. Even today, MD-11 freighters remain a common sight at major cargo hubs worldwide. By the late 2000s, Trijets had virtually vanished from passenger service. The speed shocked many people in aviation. But for airlines paying attention, the writing had been on the wall for years. The Trijet collapse created clear winners and losers among world airlines. American Airlines had been a major DC-10 operator, but were early adopters of the Boeing 767, quickly transitioning transatlantic services to the more efficient twin. This gave them massive cost advantages over competitors, still operating fuel-hungry Trijets, same routes, 30% lower operating costs. United Airlines followed a similar path, replacing their huge DC-10 fleet with 767s and later 777s. The fuel savings were enormous and helped them weather industry turbulence. Conversely, others such as Panama struggled with costly fleets. Their trijet and quadjet reliance contributing to financial collapse by the early 1990s. Delta's transformation was even more dramatic. The airline had built much of their network around 727s and L-1011s, but rapidly transitioned to 767s and later A330 for long-haul routes. European carriers like Iberia, major DC-10 operators, made similar transitions to twin-engine fleets. The efficiency gains were critical as European aviation faced increasing competition. But some airlines were caught completely off guard. Carriers that had invested heavily in Trijet fleets. They found themselves stuck with expensive, inefficient aircraft just as fuel prices spiked. Many smaller airlines couldn't afford transition costs and were forced out of the business. The competitive disadvantage was simply too great to overcome. The lesson was brutal. Airlines that recognized the efficiency trend early and adapted accordingly gained lasting competitive advantages that persisted for decades. In commercial aviation, being behind the technology curve isn't just expensive, it can be fatal. Despite their rapid extinction, Trijets left permanent marks on aviation. The technological innovators were revolutionary. The L-1011 pioneered autoland capability, automated descent control systems, and advanced flight management that every modern airliner uses today. The L-1011's cutting-edge cockpit with automated systems like Autoland set a new standard for aviation technology. Those systems, they weren't just convenient. They became the foundation of modern aviation automation. The Trijet era also drove critical safety improvements. DC-10 accidents led to major changes in aircraft certification requirements, cargo door design standards, and engine mounting systems. Modern aircraft are significantly safer, partly because of the lessons learned from the DC-10's failures, new redundancy requirements, improved structural standards, and better emergency procedures. They all trace back to those tragic accidents. But the safety lessons came at a terrible cost. The DC-10's reputation never recovered from those early accidents, even after problems were fixed. Culturally, trijets represented the romance of the jet age. The 727's distinctive rearranging configuration and ability to operate from challenging airports made it beloved by pilots and passengers worldwide. Many aviation enthusiasts still consider it the most beautiful airliner ever built. That unique profile with 3 engines clustered at the rear was instantly recognizable anywhere in the world. DC-10S and L-1011S opened international travel to millions of passengers. These aircraft, well, they made transatlantic flying affordable and accessible, connecting cities that had never had direct airline service before. For airline enthusiasts and aviation historians, trijets truly hold a special place. So, why were trijets the future until they weren't? Looking back, the clues were always there. Fuel crises, complex maintenance, fragile trust, and regulations that were never carved in stone. Together, they sealed the fate of the 3-engine era. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?